Now we're going to test our Microsoft Visual C++ 2005 Express Edition compiler, which is actually easier done than it's said. Here's all we need to do. After you install the Express Edition compiler, you click on Start, of course, All Programs, and then the Visual C++ Express Edition item. Now don't go right to the compiler. That brings up the IDE. We want to click on the Visual Studio Tools, then the command prompt. Then we will type CL to run the compiler, and we'll confirm that it actually ran. Let's go over and do that. Here you see that we have clicked on Start and All Programs, and now we have to scroll down to Visual C++ 2005 Express Edition, over to Visual Studio Tools, and then we select the Visual Studio 2005 command prompt. That will bring up a normal command window, and you can see that we are in the Program Files, Microsoft Visual Studio 8 VC. Now this command prompt has also had a number of environment variables set so that the compiler will function properly. If you go straight into a normal black command prompt and try to run the compiler, it most likely will not function properly. And what's worse, it may appear to function properly, but then not link properly and give you a lot of trouble. So only start the command line the way that I just showed you to start it. Otherwise, you'll have lots of additional problems on top of programming in the language. Now to test the compiler, it's simply CL, enter, and we see that the Microsoft 32-bit C and C++ optimizing compiler for x80x86 is actually running. And it also gives us a usage line that we would type in CL and any kind of options that we might want to compile, which we won't really be working with that, the file name that we're going to compile, and then any kind of link options after the /link identifier. So pretty simple, and we have a working C compiler. Just, of course, type exit to get out of this, and that's what we needed to do. Next, we're going to go on and take a look at putting a C compiler on a Linux system, which is about the same process, but we'll take a look at that next. We want to talk a little bit now about putting C onto a Linux installation. If you've been through a Linux installation, you probably already have a good C compiler, GCC, installed. If you have not gone through a full installation, rebuilding your own kernel, that sort of thing, and you're just looking to learn C, then let's take a look around at what I have installed is Ubuntu, UBUNTU. It's another distribution or distro of Linux. So we'll switch over to that, and I'll show you what you can do inside Linux to confirm or at least upgrade the C compiler that you have there. Let's switch over to my workstation, and this is my desktop inside Linux, inside Windows. What we do is click on System, Administration, and then come down here to what's called the Synaptic Package Manager. Now your particular Linux will have, need a password there, will have a package manager that comes with your distribution. So Red Hat would look different than SUSE or Ubuntu that we're looking at here. All we have to do in the package manager is search, and we'll search for the GNU C compiler, GCC. We'll click search, and it should just take a second to search through the libraries. And there's the CPP. That's the C++ compiler right there. Now, all we have to do is look at the installed version and the latest version. And they match, so we're up to date. We have everything that we need to do C++, or in our case, just simple C programming. So I don't even have to check mark this or do anything with it. If I did check mark this and click apply, I could install or upgrade the GNU C compiler or the C++ compiler and get a fresh version. You could close the package manager, and that's all there is to it. If you want to read more about the C compiler, the GNU CPP, simply go to gcc.gnu.org. All kinds of documentation on installation of the compiler, various platforms that it can be run on, how to test it, lots of documentation so that you can go much farther than we're going to take you beyond just the C language. You can go into all of the linking and other kinds of things that we'll see a little bit of later on in the tutorial here. But right now, we just want to make sure that that compiler is out there and running and relatively up to date. We're not going to use an integrated development environment, an IDE, or anything like that, even on Linux. We're just going to use the simple command line or terminal session, just like that, so that it's nice and simple, and we only have to worry about the language itself and not some IDE getting in the way. So onward, we will go and learn how to test our compiler and make sure that it's actually out there. Now we're going to test our GNU C++ compiler, or just C compiler. It's pretty simple, but I want to show you something interesting in Linux about the CPP and what it's called. Let's switch over to our Linux, and as you can see, we have our term session running. That's all we really need. If you get your system started up and you're used to just a clean desktop, maybe some icons out there, you may not use the terminal very much. Well, the terminal is right up here, and in the other operating system, the other big one, Windows, that's called a DOS prompt, or the old disk operating system command prompt. Well, here it's a term session or terminal, and you saw the word terminal pop up there probably at the top, and that gives us control over the system. It gives us a command line processor that we want to be able to use to keep the IDE and all the graphics and all that out of our way while we're learning the language. So now that we're here, we've gone through all the updating, the CPP, the package manager, the RPM, whatever it is your particular flavor of Linux requires, and we believe that there's a compiler running, or available, I shouldn't say running. Let's now make it run. GCC is the compiler that we installed, and we'll put a space, a dash, and a V for version. We want to learn the version that this compiler is going to run, just to kind of make sure it's out there. Well, there it is. There's i486 Linux GNU, and a lot of configuration information that we don't really care about right now. But there's our GCC version 4.03, and it's on the operating system, Ubuntu 4.03, as you can see that, so on. Well, GCC, the GNU C compiler, that's one word that can be used to start this thing. There's also G++ space dash V. Gives us exactly the same information because it's pointing to exactly the same program. This G++ is just a different way of asking for the C++, the GNU C++ compiler to run. What you'll find in the ANSI C book, the KNR that we're going to use, is they call it CC, the C compiler, because that's what it was originally called when it was written for Unix. If we do a CC space dash V for version, exactly the same information, because they understand that a lot of older commands use CC for the C compiler. So they get that CC pointed or linked over to the new compiler that we just installed so that everything runs properly. Just wanted you to know that if you want to use the CC command that we're going to see in the book, that's quite all right, and it will work just fine. Okay, we've tested our C compiler under Linux, and we're going to move onward. We did all this work to install a compiler on Windows and to install a compiler on Linux. Just what is a compiler anyway? A compiler is a program that converts human-readable instructions into computer-readable instructions one time. A compiler takes longer generally because it rearranges or compiles or optimizes what is then called object code. We're going to learn how to write a lot of different instructions and statements and functions and things like that. And they're not necessarily going to be in the best order for the computer. They'll be in the best order for us to think about how things should work, but the computer may have a better idea, and the compiler knows what it takes to make better machine executable code, and that's what it's going to do for us. An interpreter is a program that converts the source code or human instructions into the machine instructions each time you interpret or run the particular program. An interpreter starts interpreting each of the instructions, go to here or print this or take input from the keyboard. It interprets those immediately and appears to produce results more quickly. However, the interpreted program will almost always be slower than a compiled output or compiled program. An interpreter is very good for reviewing the functionality of a program with your customer. And you can sit down with them and say, what if we change it like this? And what if we do that? Is that more what you want? So it's very good for development reviews. When we're compiling, the source code goes into the compiler. It is optimized and turned into some standard code that the compiler has within it, which produces object code. Now, the object code cannot run by itself. The object code generally needs to load DLLs, dynamic load libraries, or other code that is necessary for the program to actually function. We don't need to write all the operating system programs over and over and over again, so there are libraries of that code already created that will be linked in with our program. And of course, to do that, we use a linker. A linker takes the standard libraries, our object code that we created from our compiling process, and any user libraries that we might have made or our company might have made. A number of programs that get used a lot to maybe run a piece of machinery that our company has created or something like that. All of those libraries and object code get linked together by the linker, and that produces an executable program, something usually in the Windows world that ends with .exe that we can actually run on our computer and cause some work to be performed, which is why we're learning how to do this. So to recap, a compiler, the program we've just installed, is going to take our C programming instructions and it's going to turn them into object code. The link step is then going to link our object code with some standard libraries that already exist and produce an executable code. So we're going to see all that happen as we do this, but I want you to understand the difference between source code, which is what you can easily read, written in a form of English, object code, which is the output of the compiler, and then executable code, which is a combination of object code and other standard libraries, and maybe even some user libraries, so that we can get an executable program to run. So let's go forward and enter our first program and compile it and link it and execute it, and then I'm going to give you an assignment, a little bit of homework to do.